Welcome back to another exciting episode of Dave's Does Math from Home. This is part 3 of our video series on functions and level curves. We've talked about planar functions, we've talked about spheres and ellipsoids, we've done level curves for several of those things. We talked about my cool mountain shape. I like that one. I don't think that one has a real name. I just like talking about it. We still have a couple functions that we need to talk about and look at level curves for. So I promised you paraboloids, and I am prepared to deliver paraboloids. So let's talk about a paraboloid. Paraboloid is what happens when you get something like f of xy equals x squared plus y squared. It's sort of like your standard issue. Your standard issue two-dimensional parabola is y equals x squared. So when we switch it into 3D, we have z equals x squared and y squared together. This is going to make a paraboloid looking thing. And we have also talked about before how the x squared plus y squared sort of configuration here basically means you're talking about distance from the origin on the plane. So you could think of this as z equals the radius squared, the distance on the xy plane, that distance squared, that's going to be your height. I'm going to do level curves over here. The level curves are z equals 0 on the bottom. Let me get a bunch of different colors for us. This is going to be exciting. Okay, z equals 0 is on the bottom. If I want z to equal 1, that means I'm looking at a circle of radius 1. This is z equals 1. So as you move out from the surface, you get a circle of radius 1. If I want z to equal, let's say, 3, that means the radius has to be the square root of 3. Maybe I should make z equal 4. If I want z to equal 4, that'll give me a radius of 2. So this is z equals 4. Hopefully the red is showing up on the camera. Let me see. Yeah, it looks pretty good on my end. Let's switch to green for z equals, I think our next step should be z equals 9. Z equals 9 is a circle of radius 3. So these are our level curves. And if you're looking at the distance between the level curves, that's always going to be 1. This is radius 0 is a dot, radius 1, radius 2, radius 3. All of these things are just incrementally 1 additional unit further away from the origin. But the thing that makes this a paraboloid is that to move 1 additional unit farther away from the origin, you have to take increasingly many steps forward. So z equals 0 is right here. It's actually on the surface. If each of these z values is like a step, then z equals 1 is 1 step forward. Z equals 4 is 3 more steps forward. Z equals 9 would be 5 steps further away from that. So every time you go out 1 unit, you're going increasingly farther and farther and farther away from the board. The next one would be z equals 16, and then 25, and you're at a radius of 5 here, and you're 25 units away. That's what's giving it this parabolic shape, this sort of increasing steepness that's coming from the levels of the level curves, essentially. If we want to try and sketch this in a 3-dimensional looking thing, you end up with some sort of like parabola. It usually gets drawn, if you're going to try and like sketch in things, we'll have little squares here. Okay, never mind. I can't do it. Should not have tried. Find a online 3D graphing calculator and plug in this function, or Google paraboloid. You can see what these things kind of look like. You can probably imagine it. It's like a bowl. It's a bowl with increasingly steep sides. in the same way that a parabola is a curve with increasingly steep sides. So that's a paraboloid. Those are the level curves for a paraboloid. I want to do a different kind of function as well. I want to talk about something that looks like z equals, let's say, x squared minus y. This is a polynomial. It's a polynomial in two different directions. We have x's, we have y's. Right now they are separate. There's no terms that combine the x's and the y's together. We have one x term and one y term, which is going to make the level curves for this pretty easy. Level curves should look like z equals 0 would be x squared minus y equals 0, so y equals x squared. That's just a parabola. This is the z equals 0 level curve. Z equals 1 level curve. Actually, let's go up to 2. Z equals 2 level curve will be x squared minus y equals 2. So y should be x squared minus 2. So that's this same parabola, but down 2 units. Gotta make that thicker. This is z equals 2. So as you come out, the parabola sort of drops a little bit. If I wanted to do a z equals negative 3 level curve, I would have x squared minus y equals negative 3, which would give me y equals x squared plus 3, solved for y. So that's the same parabola but moved up 3 units. So if you imagine the purple being out here and the black being on the surface and the red being behind the surface, you can kind of see that the shape we have here, it's like a little sloped canyon thing. Cross sections of this will be parabolic, but as you move out from the board, the whole thing sort of slides downwards. So it's sort of like a half pipe. If you've ever snowboarded or skateboarded or anything, this is like a half pipe shape. I guess you'd have to set some pretty strict domain restrictions so that you'd have like edges here for it to be a real half pipe. But it's vaguely half pipe-ish. Yeah. So it's linear in y, parabolic in x, comes out of the board on z. That's this other function. Do I have other functions that I need to talk to you about? We got mountains, planes, spheres, ellipsoids, paraboloids, level curves. I think that's about it. There's some interesting domain questions you can wrestle with. Those are super fun. You all remember how domain works, so I don't think that I need to give you a bunch of examples of that. You can't divide by 0. You can't take the logarithm of a non-positive number, and you can't take the square root of a negative number. So look out for those 3 things to determine domains, but you get to look out for them with 2 independent variables, which is a fun, new, exciting adventure, but it's not like a tremendous challenge, I think. So that should hopefully be pretty straightforward. And I think that's about all I have to say about section 15.1. Good luck.